Hey, this is Leach with Simpson Math, and today we're looking at graphing quadratics when they're not in a transformation vertex form. So it's what's often when they're in standard form. So we looked at this last time in the last video, this quadratic, and we did all the things. We did the end behavior. So this particular quadratic, we can actually factor it, and it gets it into our transformation form where I can use my A, B, C's, and D's and just shift the thing around. Our next example, we won't be as lucky, and so we'll see what happens then. But what I want to point out are some of the more quadratic specific questions that I'll be interested in getting from you. So when we come across quadratics, let's also find these 5 things. Let's find and graph the axis of symmetry, the vertex, one additional point we can get from using symmetry, and I also want to know the domain and the range. I won't be asking about domain and range for other polynomials because finding the maxes and mins of those, like I said, requires calculus in some cases. So we're going to be avoiding a domain and range with that because the domain should always be negative infinity to infinity. Just the range, especially if it's even, can be a bit tricky. So first thing, let's talk about the axis of symmetry. So the axis of symmetry is this formula. It's x equals negative b over 2a. Now, negative b being divided by 2a should feel a little bit familiar. If you think back to the quadratic formula, do you see that negative b over 2a right here? That is the axis of symmetry, because that's what happens. We actually, this negative b over 2a, this is the middle of the parabola, and then we add or subtract this square root of b squared minus 4ac over 2a, and we add or subtract that thing, and that's the distance our x-intercepts or the roots are from that middle of the graph. So I could unadd the fraction, and notice that we get this negative b over 2a plus or minus this bit in the quadratic formula. So that is our axis of symmetry. That's where that comes from. So if you remember the quadratic formula, then you'll be good with the axis of symmetry. All right, so in this particular quadratic, I can then just substitute in my b and my a. So my b is 6 and my a is 1. So we have negative 6 over 2 is negative 3. So my axis of symmetry is, and this is important, it's this equation, x equals negative 3. It's not just negative 3, it is a vertical line, x equals negative 3. So make sure to include the x equals part. All right? The next thing is the vertex. Well, our vertex is on the axis of symmetry. Let me go ahead and show you our parabola. We've already graphed this from the last video, so this isn't a spoiler. But let's take a look at this. So here's my axis of symmetry, this vertical line, x equals negative 3. And my vertex is always going to be on the axis of symmetry. So what I could do to find my vertex, which I already know that we knew it from here, but what if we didn't? What we would need to do is to plug in my x value for my axis of symmetry into the function, and that y value is going to then be the y value of the vertex. So we get this. Since it lies on the axis of symmetry, evaluate the function at the axis of symmetry. So g of negative 3, and this negative 3 comes from right there, from my axis of symmetry. So negative 3 squared is 9, 6 times negative 3 is negative 18, and then add the 9. And so 9 plus 9 is 18, subtract the 18, and we end up with 0. So that's where we have a vertex at negative 3 comma 0. All right, looking back at my graph, I knew from my y-intercept, I knew my y-intercept was at 0, 9, just from the problem. And this is an axis of symmetry. So 3 units away from my axis of symmetry is my y-intercept. Well, that means that 3 units away on the other side is going to be another point on the parabola. So I can plot that point, and this point here is this negative 6, comma 9. So I know that point from from knowing about symmetry. So there's my symmetric point. And then lastly, let's take a look at our domain and range. So my domain, this is a parabola, so it's going to go from negative infinity to positive infinity. In fact, if you think about all polynomials, they will have a domain negative infinity to positive infinity. But these even degree polynomials, they either start high and end high or start low and end low. So we have to be mindful about their range. So when it comes to a quadratic, you're able to find the highest and lowest point, which is that vertex. And so I'm starting at 0 and then going up to infinity, so 0 to infinity. All right, let's take a look at one more parabola example to settle this into our brains. So first, let's do the new in behavior stuff. So what's our leading coefficient? It's -4, so that means that we are going to be falling to the right. And then since this is an even powered degree, we're going to then be also falling to the left. And we have 2 roots, we expect 2 x-intercepts, and we're for sure going to be getting 1 term. And we have a y-intercept of 0, 21. Okay, so now that we have that, let's find our x-intercepts. To do that, I'm going to need to factor. But first, always remember, when we factor this, before we try factoring this, using the AC method, we need to, hopefully you're saying, factor out that -1. Yes, we need to factor out that negative. That is very important. So factor out the negative, that leading negative, and so now we can do the AC method. So we need to multiply 4 -21, and we get -84. What multiplies to be -84 and adds to be 8? Well, that's going to be a -6 and a +14. So we can split up that +8 and factor that. And when we do, we end up getting our function is m of x is a negative 2x minus 3 and then 2x plus 7. One note about this negative, you could keep the negative like I have here, or from the very first step, you actually could have just divided everything by -1, and then the negative would have gone away, and that would be okay. So our x-intercepts are going to be x equals, or sorry, our roots are going to be x is 3/2 and x is -7/2. So our x-intercepts are going to be 3/2, 0 and -7/2, 0. I don't think I have them written down, but I should have. All right, so now let's find all the other things that we're needing. All right, so first let's do our axis of symmetry. All right, so in order to do our axis of symmetry, we need to plug into the formula. So our axis of symmetry is -b/2a. So my b is -8. So plug in that -8. So notice this is a -8, which becomes a +8. And then plug in a, which is -4. So this is 2 times -4 is a -8. 8 over -8 is a -1. So I have an axis of symmetry of x equals -1. Next, we use that axis of symmetry to find the vertex. So I'm going to plug in -1 into my function and evaluate it at that -1. So this -1 is where I'm going to be evaluating the function. So m of -1, plug in a -1 into all the places. Make sure when you square a -1, it becomes a +1. And we end up with 25. So I have a vertex at -1, 25. Sometimes I like to give myself little blanks to say, I'm going to look for this, this, and this, and I'm just filling them in. All right, at this point, let's go to the graph. Now, I do already have it finished, but let's check this out. So we can graph our points at that 1.5 and -3.5, which the 1.5 is the 3/2, and -3.5 is -7/2. I made my x scale be halves, so you could just count 1, 2, 3, 4, 5, 6, 7 halves going to the left, and that's also that -3.5. We had our y-intercept at 21, 0, 21. I have my vertex, actually first my axis of symmetry at x equals -1, and I have my vertex at -125. I should label, let me go ahead and do that. I should label my axis of symmetry. For some reason I left this off. My axis of symmetry is x equals -1. There we go. Now it's labeled. And then for my symmetric point, if my y-intercept is 1 unit away from my axis of symmetry, then that means that my symmetric point is also going to be 1 unit away from my axis of symmetry. So I'm just going to reflect this point over my axis of symmetry, and I'm going to have a symmetric point at -2, 21. And then lastly, domain and range. Well, domain is -infinity to positive infinity for all these parabolas, but my range, it goes down forever and ever, but only up to 25. So there's my domain and range from -infinity to infinity, and then for my domain, -infinity to 25 square bracket, like I said. All right, so when it comes to parabolas, I want these 5 new additional things. I want the axis of symmetry, the vertex, the 1 additional point, and then the domain and the range. Remember, once you get the axis of symmetry, you plug that in to the function to get your vertex, and then we use the distance from the y-intercept and the axis of symmetry to get the extra additional symmetrical point. All right, so there you have it. So between last video and this video, that's this complete lecture about graphing polynomials. Let me know if you have any questions, and I'll see you next time.